Okay, in this video, I'm going to go over how to download, set up, and use the basic compiler I made that converts BASIC to 6809 assembly language for the TRS-80, Color Computer 1, 2, 3, and also for Dragon computers. So we start by going to my GitHub page, which I'll have in the show links. And then the easiest way is to just go to binary versions and then download the one that matches your operating system. So if you're on Windows, you'd use that one. An old Mac OS with an x86 CPU, you'd use that one. Modern M1 Mac, you would use the Mac OS with ARM. Then there's a version for Linux with an x86 64-bit processor and Linux ARM64, which would work with Raspberry Pi type Linux installations. So anyways, I'm on an M1 Mac, so I'll click on this one to download it. And you can just download this little raw file here. And now it's downloaded. Double click to unzip it. And go into the folder. You can see all the files that you'll have for the compiler. Okay, it's not important that you know the functions of all of these files. The main one you'll use is SDECB, Super Duper Extended Color Basic. That's the IDE that you use mainly for writing your basic program. And from there, you'll use menu options to compile it and run it. Or compile it and then you can write a script that'll run and it'll copy it to an SD card that you can then run on a real Coco. Anyways, like I said, that's the IDE. And you have, this is the main compiler itself right here. But that's not important that you know the functions of those other files. Really, this is the one you want. But if you're on a Mac, we have to use Gatekeeper or bypass Gatekeeper to allow a Mac to run all of these executables. So we'll do that from the command line. We start all of these things from the command line anyways. So I'll show you that next. Okay, so from the terminal window or command line, you'll go into your downloaded folder for the compiler that you got from GitHub. And also, there's a manual on that main GitHub page that you can download and view. It has tons and tons of info, including what I'm doing here, how to set up and use the compiler. So now I'm in the folder. The important thing on a Mac is to use the special command. So to allow it to run these downloaded files on your Mac. So once you type that command, which again is in the manual, so you can just copy and paste it. But this is only for newer Mac OS. The older Macs didn't use this, so depending on what version you're running, you might not need to do this or you might. So now that that's done, we can actually execute any of these files that are executable in this folder, like the Super Duper Extended Color Basic IDE. But just quickly to let you know that these other ones do work. These programs here, like ping to CC3 background, and ping to CC3 playfield, and ping to CCSB, those are helpful helper programs that convert like pings to the background. So you can use that for games. Use that tool to create backgrounds, like scrollable backgrounds for Coco 3 games. And then there's this one for sprites. So if you want to turn PNGs into sprites, even animated sprites, you can use this tool to do it. But for now, we're just going to start the actual IDE. So on Linux and Mac, you do a // and then SDECB. On Windows, I believe you don't need the /. You just type SDECB and you should be good to go. Maybe .exe. Anyways, and that starts up the actual IDE. Okay, and the first time the IDE starts up, the window will look like this. And you can just hit no, use the defaults. And don't show this again. And then you can configure it. If you like the way it looks, use it the way it is. But if you do want to configure it, you can go to display, some settings in here, IDE colors. I typically like the original. Okay, just a little brighter. And code layout, this you might want to change to. So if you like indenting automatically, you can click on, keep that on. If you want uppercase, click on that. And you'll see everything's turned uppercase, well, except for what was in the quotes. But the actual commands will be in uppercase at that point. If you like camel toe, which I actually do prefer, you can set that or everything to lowercase, which I'm not a fan of actually. So anyways, change it to how you like. And for now, I'll turn this indenting off just so it'll look more like old basic programs. Hit OK. So the IDE itself is basically the same as QB64 Phoenix Edition IDE. It's actually a version of that, but tweaked quite a bit so it understands all of the commands that the color computer has that QB64 doesn't. So anyway, so you can type in, you can edit just like anything else. Of course, we have to do our Hello World program. And then go to compile. This is the important part, actually, that needs to be set up still. So when you go to compile, the default F11, or just hit F11 on the keyboard, it'll run this part of the makefile. But your makefile can also have different parts to it, so you can assign a command 1, 2, 3, 4, and 5 in your makefile as well. And when you click on these, it'll run that makefile with that command and do a whole bunch of things for you automatically every time. So what I usually do is set up F11, which is the default in the makefile, to automatically compile, use LWASM to assemble the compiled code, and which turns it into a binary, and then I run that binary with MAME for testing or just seeing how things are. It's a lot faster to iterate, find your problems or whatever using MAME. But then you can use, like I do, command 5, which does the same. It compiles it, assembles the compiled code, but turns it into a disk file and writes it to the SD card so I can take it and run it on the real Cocoa 3 at that point. So next thing we'll do is show you how to configure the make file. And if you're on Windows, it'll be a .bat file, but very similar ideas. Okay. So from the window or your folder with the downloaded files from GitHub, you can edit this make file or .bat file if you're on Windows. I can't remember which .bat file it is, but it'll be the only .bat file in that folder. Anyway, so then edit it. I actually like to use VS Code to edit. Okay, so in the make file itself, there's going to be a few different sections. So the first is the default, which is F11. So if you're in the IDE and you press F11 or you select it from the menu to compile with F11, this is the section that will be executed by the IDE. So you can configure this any way you would like with any normal bat file or batch file or make file. So in my example here, it says the file name it's processing. Actually, this is the line that does the compiling. And then it runs William Astl's LWASM with these options, creates a file here, and an output called new.assemblylisting.txt, which can be super helpful if you want to see what's going on in memory or different memory or locations of your program. Anyways, any of these ones with numbers are not being used at this point. So then it's going to copy the blank.dsk.disk1 or copy this and rename it to disk1.disk, and then uses deckb, which is part of the tool shed, which is included in that same folder. So all of these commands everything is ready to go. So what it does is copies your program as a .bin onto this disk1 image and saves it on as that file name that you're using on that disk image. And then at that point, if you have MAME installed, you can remove this and it'll actually run MAME. This command actually is set up for debug mode, which is super useful for debugging your programs. Or you can use XROR with these default options, or of course you can set your options like crazy and you'll be good to go. Then I said could also use a whole bunch of other commands. So command 1 would execute these commands, command 2 would execute these, command 3 would use these, 4 and 5. So for me, I like to use command 5 as an output to the SD card. So basically it does the same thing. It compiles your program, assembles your program, copies the blank disk to a new disk1 disk image, then runs deckb and copies your program to that blank disk image. And then, well, this is actually set up to bypass now, but remove any old ones. And of course, you'd want to change the volume names to match your SD card, but that's what mine defaults to. So if I am in the IDE right now and I choose command compile command 5, it would do these steps. That's it. So that's it for the bat file. So what I will do is I will enable MAME to run, and actually we'll use XROAR. Then we'll save this, and then we'll test it out with the IDE. Okay, now back at the IDE itself. Actually, the first thing we need to do before we compile is to save it. Save it. You have to give it a name. So in this case, I'll just call it T1. It creates t1.bas for us, okay? So now, when I click on compile using the makefile. So it's going to be the default again from the makefile, which is this section of code here. So it should start all of this, and once it's copied the image onto this disk image, it should start XROAR so we can test it out. So let's give it a try and see what happens. So here's XROAR. And in the background, we can see what it's done. So it's processing T1 to run through the compiler. Didn't have any errors, which is great. LWASM ran, no errors again, which is great. And it copied blank to a... Okay, now back at the IDE itself. Actually, the first thing we need to do before we compile is to save it. Save it. You have to give it a name. So in this case, I'll just call it T1. It creates t1.bas for us, okay? So now, when I click on compile using the makefile. So it's going to be the default again from the makefile, which is this section of code here. So it should start all of this, and once it's copied the image onto this disk image, it should start XROAR so we can test it out. So let's give it a try and see what happens. So here's XROAR. And in the background, we can see what it's done. So it's processing T1 to run through the compiler. Didn't have any errors, which is great. LWASM ran, no errors again, which is great. And it copied blank to a disk image. Copied our machine language program t1.bin onto this disk1 image and called it t1.bin. Then started XROAR, and XROAR ran. These are all messages from XROAR itself. So we'll go back to XROAR here, and we can see our program, T1. So we load T1, enter, and then we can execute it. And there we go.